If you're like most people, you've probably played a video game. But have you ever thought about how they work? In this video, I'll be covering how bounding boxes are used in two-dimensional platformer games. In 2D games, it is common to use bounding boxes and vector math to detect and handle collisions. An entity will be a bounding box and a velocity. To move the entity over time, we repeatedly add the velocity to the position. To detect collisions, you first have to get the broad phase bounding box. The broad phase bounding box is a bounding box that covers the entire entity, including its velocity vector. If something does not overlap the broad phase bounding box, it will not collide. To get the broad phase bounding box, you first have to check if the entity is moving left or right. If it's moving to the left, you set the broad phase bounding box's position to the entity's position plus its velocity. If it's moving to the right, you just set its position to the entity's position. The same thing applies for the y-axis. If something overlaps the broad phase bounding box, you must do more logic to determine if, when, and how the objects collide. First, you need to get the entry distances. These are the offsets between the leading edges of the bounding boxes. To get the entry distance, you first need to check if the entity is moving left or right. If it's moving to the right, you subtract the right edge of the entity from the left edge of the platform. If it's moving to the left, you subtract the right edge of the platform from the left edge of the entity. The same rules apply for the y-axis. Now you need to get the exit distances. These are the same as the entry distances, except it's the faces that are facing away from the collision. Now that you have the entry and exit distances, you can get the entry and exit times. These are a number between 0 and 1, and you get them by dividing the distance by the velocity. The number also needs to be positive, so you take the absolute value of that. Now that you have the entry and exit times, you can finally determine whether or not there was a collision. If the exit time on the x-axis is less than the entry time on the y-axis, or the exit time on the y-axis is less than the entry time on the x-axis, then there's no collision. Otherwise, there is a collision. Now that you know if there's a collision or not, you need to figure out if it's the horizontal edges that collide or the vertical edges that collide. If the entry time on the x-axis is less than the entry time on the y-axis, then the vertical edges collide. Otherwise, the horizontal edges collide. Now you have everything you need to solve the collision. One way to handle collisions would be to multiply the appropriate velocity vector by the appropriate entry time. Or you can move the entity to the point of collision, and then readjust its velocity. If you try to slide an entity across a surface that's made up of a bunch of rectangles, it'll look like the entity is like stubbing its toe on the cracks. They call it the crack problem, and basically it's because the collisions are being solved in the wrong order. To solve the crack problem, you collect all the collisions, and then sort them by which ones happened first, and then handle the first collision and throw the rest out. And then you just continually recollect the collisions, sort them, process the first one, until there's no more collisions.